Hi guys, how are you? I hope you are fine. I'm Muhammad Saeed. Today we are going to speak about OSPF stub areas, and in this video we are going to see this topology. Here we have 8 routers here, and each router here it consists of different areas. We have many areas here of OSPF, and we have EIGRP Autonomous System 1 between router 9 and 3. In this video we are going to concentrate to focus on OSPF stub areas. OSPF stub areas like stub NSSA, total NSSA, and total stub area. And we are going to speak about the virtual link and something called the capability, OSPF capability transit. So here is our point today. We are going to speak about. First thing, we are going to configure the OSPF areas. Second one, we want to make a full connectivity between all routers. Yes, to be sure that router A can connect to the router 9 and to the router 6, and also vice versa. Router 6 can connect to the router 8 and to the router 9. And we are going to configure the EIGRP Autonomous System 1 between router 9 and 3. Here is it. We are going to configure the EIGRP between router 9 and 3 for this serial interface. And also we are going to redistribute the loopback interfaces on router 1. Router 1 here, let me show you just what we are going to do here. Show IP interface brief here. On router 1 we are going to, this loopback interface we are going to advertise to distribute it without using network. Yes, we are going to advertise to other networks just these loopback 1, 2 and 3. So let's write here just loopback interfaces 1 plus 2 plus 3 on router 1 without network command. Yes, 5 we are going to make a mutual redistribution between OSPF and EIGRP. We are going to make a mutual redistribution here between router 3 and 9. We are going to make a mutual redistribution between EIGRP and OSPF. We are going to make a redistribution among OSPF and among EIGRP. The 6th point here, we are going to make area 3 as a stub. Here is it. I want to make this area as a stub, and I want to see what's happening. And also after that we are converted to the NSSA. Yes, to the NSSA, and finally to the totally NSSA. We are going to see what is the difference between them. And now the 7th point, we are going to make area 5 as a stub area. Here is it, area 5 as a stub area, and finally we are going to convert it into totally stub area. Here is it. Final point, we are going to see the difference between, yes, this is exactly not the point, maybe this is a kind of conclusion. We are going to see the differences between totally NSSA, totally stub, and NSSA and stub areas. So let's get started now. As you see here, before everything we are going to configure OSPF areas. So let's go from here, router 8. Let's see what we have here. We are going to configure OSPF. Show IP interface brief. Look at this. Here we have many loopback interfaces. We are going to include it. Just this loopback 1, 2, 3. I want to advertise it. I don't want to advertise this loopback. So what we are going to do here, conf t, and also we are included this in our OSPF area 2 and this loopback also. So loopback 0, 1, 2 and 3 we are going to advertise to OSPF area 2. So router 2 here, router OSPF 1, I want to advertise the first thing, the serial link here. Let me just here, serial link, which is this, network 192.168.7.0.0.0.255. This is the wildcard mask. This is a mandatory, yes, even if it's this, yes, in a class full, because I want to use it here with area 2. Now we are going to advertise this network also, network, just to quickly think, 0.0.0.0, sorry, what is that, 0.0.255 with area 2, and also we are going to advertise this network, yes, 0.0.0.0.255 with area 2, sorry, 2. Be careful the kind of area, because this is very sensitive to do it. 1 and 2 and 3, just I don't want to advertise 4. Okay, so now it's just to verify to IP protocols. I have OSPF here, the router ID, this is router ID because this is the highest one, and also we have all these network are advertised into OSPF. So we are going to router 7. Do we have something here? Do we router 1? Just no problem. Router 7 here. So now go 7 conft for that show IP interface brief. Yes, we have here. I want, look at this. Here is it. I want to advertise 7.7.7 here for area 2 and 5.7 for area, yes, 1. And also I want to include loopback 7.7.7 into area 1. Yes, this is just, it's not exist. I want just to delete it like this. Interface here 01. I don't want it. No IP address. And also this one I don't also want to use it. So interface, because I don't want to make a mistake. Yes, I mean it's understood here or some mistake. So no IP address. Let's go show IP interface brief here. Yes, just this and this, and also this and this. So now go to the conft router OSPF 1. Also here we have a network. I want just this network with 0.0.0.255 with area 2. Yes, and network this with 0.0.0.255 with area 1. Yes, look at this, we have adjacencies here in this neighbor, and now we are going to advertise this loopback interface into area 1. So now go to the network with 7.7.7.0.0.0.255 with area 1. So now go to the router 5, just like this. Yes, show IP interface brief. Here is, I want to include all interfaces here with area 1. So now go to the back to router conft router OSPF 1 network, sorry, this 0.0.0.255 with area 1. The second one is 5. Yes. The last one is the loopback interface here. Wildcard mask 00255 with area 1. Yes, we got adjacencies. Yes, with neighbor 7.7.7 here. That's good. Now go to the router 2. Yes. Let's see what we have here. Show IP interface brief. Look at this. I don't want this serial. Yes, I don't want it. Yes. So now conft just to avoid any mistake. Sorry. Yes. Now interface series 01. No IP address. Sorry. Address. Yes. Now show IP interface brief again. That's good. Now conft router OSPF 1 network. I want to advertise 3 here. 0.0.0.255 with area 1. Yes, and I want to include also this loopback interface for area 1 also. So network here, this loopback interface with area 1 also. Sorry. Now I want to include this 40 for area 5. Where is it? 40 for area 5. So network this 40.0.0.255 with area 5, and I want to include this 2 with area 0. So network, here is it. Yes. Now 0.0.0.255 with area 0. This is the backbone area. So now I don't want to include this. Yes, we did for all, just like this. That's good. So now we have adjacencies also. So now that's good. Now go to the router 6. I want just to advertise. Look at this. Here's it. Just let me see. Show IP interface brief. Yes, conft router OSPF 1. I want to include this is. Yes, 0.0.0.255 with area 5. Sorry, and I want to include also this network. This 0.0.0.255 with area 5. Just this is an extra. I don't want to use it. Just to exit interface fast Ethernet 01. I don't want to delete it. No IP address. So now that's good. Now sorry, just I closed the door. So now yes, we did here. We arrive here. Now go to the router 1. I think I have one here. Yes. So now this is show IP interface brief. Look at this. I want to advertise 2.0 here for area 0, 1.0 here for area 3 just, and I don't want to include this loopback interface. Yes, 0 with any. Yes, with any advertising any OSPF, because I want to advertise all these loopback interfaces. Yes, without using network. So I want to show you how, but not in this step. Let's just finish our step here, the first one. So OSPF 1, I want just to network this loopback 0.0.0.255 with area backbone area 0. Yes, and 1.0 here for area 3. Just that's good. Now go to the router 3 here. Yes. Now show IP interface brief here. I have to include this for area 3 and this is for EIGRP. Be careful. That's good. So now go conft router OSPF1 network 192.168.1.3, so 0.0.0.0.255 with area 3, and I want to include also, I don't want to include this loopback 0 into OSPF redistribution. So now exit. So now go to the router EIGRP1. I want just to include this serial link 192. Sorry, what is that? This is network 192.168.6.0. Here is, I don't need to type the wildcard mask because this is in a classful. Don't forget the no auto summary here. And also go to the router 9. Configure also the EIGRP here. Show IP interface brief, what we got here. Look at this, we have many loopback interfaces. We are going to advertise it to EIGRP. So router EIGRP1. So now network, the first one 192.168.6.0. Here is it. I don't need a mask or a wildcard mask, so don't forget not to summary. Now we have adjacency with router 3. That's good. Now we are going to advertise this loopback with 0.0.0.255, and we are going to advertise also this 0.0.0.255, and also 101, and also 102, just like this. So now let me just to show you here, show IP route. Do I see anything here? Yes, I don't see because I didn't make a mutual redistribution yet. So now we did the first one and we configure EIGRP with 993. So now we are going to make a full connectivity between all routers here. So now what we got here, look at this. If we want to go to the router 3 first, just I want to show you something interesting here. Look at this. Show IP interface, sorry, OSPF neighbor. We have a full connectivity here between this neighbor 192.168.192.172.16.12.1. This is the route ID for router 1. Yes, and that's good. So do we have, yes, any OSPF routing? So OSPF router, OSPF here. Look at this, that's very good. Look at this. I see 2.2 here's for router 2, and I see also 6.6 for router 6. Look at this, because here's I am in router 3, and router 3 connected directly with us with the backbone area 0, and this also connected with the backbone area 0. So that's good. Now, and I should see also 5.5 here. That's good. Now I am seeing also 7.7 here. Yes, that's cool. Yes, I see it also. And also I see 4.4.0 here. .3.2. Yes, and .5. What is it? .5. Here's .5. Yes, that's good. So now let's just make a ping. Can we make a ping there to first one to the 2.2.2.2? Yes, and can we ping to the 6.6 here? Let me see. That's cool. Now can we ping to the 3.5 here? I want just to specify ping 192.168.3.5. Yes, and ping to the 5.5.5.5. That's cool. Now can we ping to the 7? Let me see. 7.7.7.7. That's good. So now I can ping from router 3 to all routers until here, but I can't see this router. I can't see router 8 and this serial link as well. So show IP route OSPF again. Look at this, what we got here. we see all OSPF areas as enter area. Yes, with IA, this means that IA it's enter area, because all OSPF areas here are directly connected with the backbone area, but this area 2, it's not directly connected with the backbone area. So what is the solution here? The solution here, I want just to make a virtual link, yes, for area 1 here between router 2, 5 and 7. So now I want to make a virtual link here to make a full connectivity with router A to the router 3 and with other routers also. So if you go to the router 8, just I want to show you something here. Show IP route, what we have here, I don't see anything. Yes, I don't see anything, even in this router also, even in this router. So why? Because this router is not the backbone area. This is area 1 and area 2, they are different area. So the rule says all areas should be connected to the area 0 with the backbone area to make a connectivity. But what we can do if we don't have a backbone area, maybe in some circumstances here, like this. So the solution for this situation is to make a virtual link in this area. Actually, in this area we have two choices to do it. I can see, or I can do the virtual link between router 2 and 5 and between router 5 and 2. Look at this. If we do this, go to the router 2 here, I will just show IP OSPF here. Look at this. And also I want to concentrate on this command, number of areas transit capability. This is 0 here. So now that's good. I want to concentrate in area 1. Here is it, area 1. I don't have a virtual link, and also the capability transit, it's not enabled. Go to the router 5. Just want to check it. Show IP OSPF. Do I have? Yes, transit capability 0. And also I don't see any virtual link. So now go to the router 7. You can verify virtual link by also this command. Look at this. Show IP OSPF neighbor. Now you should see the virtual link. If you did the virtual link here, you can see the virtual link like interface. I want to show you now how. So go to the router 7. Yes. Show IP OSPF. Just I want to see the transit capability here. I don't see any transit capability for area 1. So that's good. Now I want to solve this by two solutions. I want to make a virtual link between router 2 and 5, and also virtual link between router 5 and 7. This is the first choice or the first solution. The second one, I want to make a virtual link between router 2 and 5. Look at this. And I want to make a virtual link between router 2 and 7 directly. But here I want to use a second command to make a full connectivity. I want to show you how. First thing, I want to just to try the first way. I want to make a virtual link between 2 and 5 and 5 and 7. Go to the router 2 first. Yes. And to make a virtual link, very important to see or to verify which router ID. So show IP OSPF again. This router ID for router 2, 2.2.2. That's good. Now router 5, what is that? Show IP OSPF. Router ID is 5. So now the command, it will be this. Router OSPF 1. I want area 3 to make a virtual link. Yes, with the destination. I'm router 2 destination to the router 5 with the OSPF ID. Yes, this is a good, very important. This is the ID. It will be like IP address. So now 5.5.5.5 like this. And I want to go to the router 5 conf t router OSPF 1. And also I want to make area 1 with virtual link 2.2.2.2. So now let's do this. So yes, I have a new adjacencies here. That's good. Now if you go there and show IP OSPF neighbor here, look at this. Look at this. I have a virtual link, yes, between router 2 and this neighbor router 5. That's good. And also I have a connectivity between direct connectivity between router 2 and 5 and this fast Ethernet 00. So that's good. Now let's show IP OSPF again. I want to verify. Yes, that's good. Now area 0, this is area 1, sorry. I have this is virtual link endpoint. This is a transit capability, what I want to do. So look at this, I want to do this. So that's good. Now in router 5, just I want to make no capability transit. Just I want to do this command. Be careful to do this command. Yes, after that I want to enable, but now I want to disable it for many reasons. I want to show you how. So in router 2, now can I see router 8 show IP OSPF? Let's see. Show IP root, sorry, root OSPF. Yes, I don't see it yet. I don't see router 8 yet. So now that's good, because I didn't finish my virtual link yet. So I want to make a virtual link between router 5 and 7 here, conf t. I want to make router OSPF 1. I want to make a virtual, sorry, area 1 with virtual link. Here's I want to see what is the OSPF ID for router 7. This is very important to verify it, because not everything is the loopback interface. It will be the highest loopback interface. Show IP OSPF. Let me just to see it. Here is it. I have 7 to 7. That's good. So 7 to 7 to 7 to 7. And now go to the router 7 and conf t router OSPF 1. Now to make a net, sorry, area 1 with virtual link 5.5.5.5. So now I should see the new adjacencies between 5 and 7. So now can we, come on, give me some shooting. Yes, that's cool. Now show IP OSPF neighbor here. Look at this. I have virtual link between router 7 and 5. Look at this. I am in 5, and I have virtual link between 5 and 2. So that's good. Now go to the router 7. Show IP OSPF neighbor here. Regard. Yes, I have a virtual link between 7 and 5. Yes, that's cool. So let's go show IP OSPF. Yes, like this. Look at this. I have, this is transit capability 1. Yes, this is for area 1. Look at this. This area 1. I have, this area has transit capability. I want just to make it transit. I don't want to disable it. So now let it as it is. So now let's go to the router 2. Can I see router 8? Yes, now I can see router 8 also with its loopback interfaces, which I advertise it, and also I see this. So now that's cool. Can I ping to them? So 8.8.8.8. Yes, I can ping. So I can ping, and can I ping also to 172. That's sorry, 192.6.7.8. Yes, I can ping to this interface. Yes, from router 2 to this interface. So go to the router 3. Can I ping to the router 8? Because I want to verify. I should see the full connectivity here. I want to make a ping to the 8.8.8.8. Yes, show IP root OSPF. Sorry. Now I can see it. I can see 8 here. and also the loopback interfaces 1, 3, and 2. This is for router 8. So now that's good. This is the first. So the first thing I did the virtual link between 2 and 5 and between 5 and 7. This is the first way to solve this problem. The second way is to make something strange here. I want just to make a virtual link between 2 and 5 and between 2 and 7. So I don't want to make a virtual link between 5 and 7. So this is my point here. So what I want to do here, I want to just to disable the virtual link which I did it before between 5 and 7. Go to the router 5, conf t router OSPF 1. Just I want to disable, yes, here is 5. I don't want to disable this, yes, and go to the router 7 also, conf t OSPF 1. I want just also to disable this, yes. So that's good. So now the adjacency is down. Now go to the router 2. I want to make a virtual link between 7 and 2 also. Here I want to make this area 1 virtual link 2 to 2 to 2 to 2. This is, we are in 7 now. I want to make a redistribution, to make a virtual link with router 2. So here is it. So now go to the router 2 and show IP OSPF neighbor just to verify it. Yes, I have with 5, and also I should see I will have with 7. Look at this. This is mismatch area ID with backbone. Yes, with this the virtual link. So that's good. So conf t router OSPF 1 area 1 with virtual link 7 to 7 to 7 to 7. This is not directly connected with 2, but it will not work. It will work. Yes, it will work. But how? We will see. Now just hit enter. Now I have a new adjacency. That's good, because now the virtual link, they are matched with 7. So now let me just to show IP root OSPF. Can I see the 8? Yes, I can see 8. Here is it. And I can see also this. So that's good. So now can I ping to them? Let's see. Ping to 8.8.8.8. What is that? I can ping. I can see this network, but I can't ping to them. So let's go to the router 8. Let's see, can I ping to other routers here? Let's see. Show IP route here. That's cool. I have almost all routers here, all networks, sorry. I have 2.2 here for router 2, and I have 5.5.5. Yes, with 5. That's good. And 6.6 with 6. This is the last one. The far away also, here's I have .1 here. That's good. And .2. That's cool. And .3. Can I ping? Let's see. Sorry. Ping with I want to ping to the router 2 here with this loopback interface. Can't make a ping. So what's the problem here? What's the problem? So now let's see. I can see it's something strange, isn't it? I can see yes, I can see it. I can see the network. Here is it. I can see it. So let's go to the router 2, and also I can see 8.8. So go to the router 2, go back just. Look at this. I can see 8.8, and here is it. I can see 2.2. So this looks like a full connectivity, isn't it? Sorry, with this and this. So what is the problem here? I can't make a ping. I can see it in my routing table, but I can't ping to them. So let's do the trace route here. I want to show you just 2 to 2 to 2 to 2. I want to see where is the packet is dropping. So it goes out to the 7.7 here, but it's not go after router 7. So look at this, it's not go after router 7. So it's go to this serial to this point, but it's not go after that. So let's see what's the problem here. So now what we have here, what is the problem? Let's make a ping again. I can do this. The packet, it can reach until this point and it does not go further beyond this router 7. So as you remember, I did something strange here in router 5. Go to the router 5. I did this command. Do you remember it? No capability transit. So this command is very important on router 5 to enable it. Why? Because here is router 5 or router 2, sorry, it doesn't have a directly virtual link connected between router 7 and 2. There is a virtual link, but it's not directly connected. Yes, there is router 5 in the middle. So router 5, it's responsible to make a transit to this virtual link from router 2 to 7 and from router 7 to the 2. So here is, I need to enable this capability transit. So now conft router OSPF 1 with capability transit. Before that, I want to show you something interesting here to do this command. So now make a ping IP protocol. This destination is 2.2.2.2. Repeat account, I want to make just 10,000, just because I want to show you here what we got it. Look at this. Now, until now, I can't see any adjacencies. I can't see any ping. Yes, doesn't reach it. So now, if I did this, enable the capability transit in router 5. Look at this. Now, look at this. I have the ping now. So that's good. So capability transit is very important. So just that's enough, guys. Yes. So now the capability transit here is very important to enable it. Why? Because router 2 and 7, we don't have a direct connected with each other. So we did a virtual link between 2 and 7, not 5 and 7. So this is very, very important to do it. So now router, we did the configuration OSPF and HRB, and we make full connectivity between all other routers except this router, because we need a mutual redistribution. So our fourth, let's make redistribute loopback interfaces. Yes, we didn't yet. I want to make a redistribute here. Look at this. I want to redistribute loopback interfaces on router 1, 0, 1, 2, and 3 without using a network command. So if you remember here, go back to the router 1 and show IP interface brief. Sorry. Look at this. I have these loopback interfaces and I didn't advertise it by network command. Let's see, just show IP protocol. Look at this. I advertised just 192.168.1.0, which is this for area 3, and 2.0 for area 0. I didn't advertise any of these loopback interfaces by network command. So what I want to do here, I want to advertise it without using the network command. So what we have to do here, this is a very nice command, show IP OSPF 1. I want to make a redistribution command. Redistribution. Yes, redistribute. Here is it. I want to redistribute which is connected to me, which is connected to the router 1. So I want to make connected. Don't forget to use subnet, because OSPF here, it deals with classful, so it doesn't, yes, deal with classless. So this is very, very important to know it. So now hit enter now. Now on router 2, you should see, before that I couldn't see 192.172, here is it, 172.10.1.11.1.12.1. so now let's go to the router 1. I can't see it now. Can I see now? Should be OSPF. Yes, look at this. I can see it here. 10, 12, 11 and 12. I can see it by E2. Look at this, E2 external OSPF by E2, and the E2 is the default. Yes, it's the default external route for OSPF, which has 20. Yes, metric with 20. So that's good. We did this point. We redistributed the loopback interfaces on router 1 without using network command. So can I see it in router 8? Just go to the router 8. Can I see this? Show IP route OSPF. Yes, look at this. I can see it. I can see E2. Here is it. Because this is directly with 1 and 192.16.12.10.11. So that's good. Can I make ping to them? Ping to the 1.1.1.1. Yes, I can ping. So now that's good. So now go to the 5th point. Here we want to make a mutual redistribution between OSPF and EIGRP. So now go to this router. I want to make a redistribution between router 3, between OSPF, and EIGRP, and we want to make this command in router 3 because router 3 here it's the ASBR, Autonomous System Boundary Router. So this is very good points to go to the router 3, and now let's just see what we got here. Show IP route OSPF. Do we have anything here? See, I see all routers here. That's good. So now show IP route EIGRP. Can I see EIGRP? Yes, I have this EIGRP. So I want to redistribute this EIGRP routing table into the OSPF, and I want to redistribute this OSPF routing table into EIGRP. So what I want to go this command router to OSPF, I want to just first in the OSPF I want to redistribute this EIGRP into OSPF. So I want to make a redistribution here, EIGRP Autonomous System 1. It is very important to make subnet, because subnet here I want to advertise classful and classless. So this is very important to do it. Don't forget it. So now hit enter now. That's good. Now if I go to the router 1 to see the router 9 EIGRP network, so go to the router 1 and show IP route. Can I see anything here? Yes, I can see here 172.16.1.1.1.100.2, and I see 9.9.9. yes, by E2, and E2. That's good. So that's a good one. Yes. And can I see it in router 8? This is the farthest one. So go to the router 8. Can I see it? Yes, I can see them. Here is it. And this network 9.9.9. So that's good. Can I make ping to them? Make ping to the ping to the 9.9.9.9. I can't make ping yet. Why? Because it's I didn't make a redistribution OSPF into EIGRP. So I want to go to the router EIGRP 1. I want to make a redistribution here, OSPF 1. This is very important to do the metric here. Yes, very important. So before that, I want just to go to verify the OSPF metric on this serial interface. I want to see the bandwidth, I want to see the delay, I want to see the MTU, I want to see the reliability, all commands here, all key values. I want to verify it just like this. Do show IP interface serial 00 Is it 00? Let's just show CDP neighbors. Serial 00 with router 1. Yes, serial 00. Yes. So now show IP interface serial 00. Let's see. The MTU is 1. Yes, that's it. 1500. So show interface serial 00. Now look at this bandwidth. It's 1544. This is the delay. The reliability is 255. That's good. And the MTU is 1500. So that's good. Now go to the conft router EIGRP1. I want to redistribute OSPF 1 with metric. The first metric is the bandwidth. What is the bandwidth? The bandwidth is this. Sorry. What is the bandwidth here? Yes. So just like this. And what is the delay? The EIGRP delay. The delay is equal this. Yes. Microsecond. And in microsecond, here is it. What? Let me just see. No problem. So now, yes. Now go to, because we have here 2000, just not 2000. The third one is reliability is 255. The MTU, the effective bandwidth metric here, I can use like this one. It's not important. Now the MTU is 1500. So now just hit enter. Now go to the router 9. I should see the OSPF show IP route. Yes, I can see the OSPF networks by DEX, which is external route by EIGRP for EIGRP. So that's good. Now go to the router 8. Now here is router 8. Now I want to make a ping to this. It should be make a ping. Now it's working now. Yes. So that's good. Let's go back. So we did the mutual distribution between OSPF and EIGRP. Now we are going to see our main topics in this video, which is the stub areas. I want to make area 3 as a stub area, then converted into an SSA. So what I want to do here, I want to make area 3 here to make a stub area, and I want to see what's happening. So go to the router 3. Be careful, router 3 here is the ASPR and router 1 is the ABR. So that's very good explanation. Now go to the router 3 and I want to make area, sorry, yes, I am inside the EIGRP. So router OSPF 1 area 3 with a stub area. Look at this, I did stub it. So I want, look at this, he gave me warning message. He says, hey, be careful OSPF, this is the ASPR. Yes, this is the ASPR. So router is currently in the ASPR while you having just stub area. So can router 3 redistribute the EIGRP into OSPF if I did the stub area? Let's see. Go to the router 4 and go to the router 1 also and make this area stub area also. So go to the router 1, conft router OSPF 1. I want to make a network area 3 with a stub. So now I should see the new adjacencies. Yes, I see the new adjacencies here. So now go to the router 1, show IP route. Can I see? Look at this. Now I can see the external. Before that, can see the external here. Look at this. E2 499. and E2 for 172.16.100.1 and .100.2. It is it. But now I can't see the external route. I can't see the EIGRP routing table here in router 1. So why? Look at this. I did a stub area in area 3 here, but be careful, because here is router 3 is the ASBR router, and ASBR router will replace LSA type 5 with type 7 to redistribute the externally. So now if I did this if I did this area ABR, it will not work. Yes, it will not work, because the ASBR, it should redistribute the external route into the internal by not stub area. Stub area it will not work with this, because stub area it deals with LSA type 5 and ASBR wants LSA type 7 to redistribute the external. So just go to the router 3. I want to show you to verify the database. Show IP OSPF database here. Look at this. I can see router 7 LSA type 7 here. And also if you go to the router 1, let's go there. Show IP OSPF database. I can see also. Just let's verify it. I can see LSA type 3. I can see type 5. Look at this. Here is type 5. But type 5, it's for ABR, not for ASBR. Yes, this is for ABR router to take the external and to distribute it. So this is very, very, very important to know it. So now what I want to do here, I want to convert router area 3 into an SSA. So go to the router 3. Now conft router OSPF 1 with area. I want just to make just no, and go to the router 1. Yes, conft router OSPF 1, and here is also no. Now I want to make an SSA like this, area 3 with an SSA not so stubby area, because not so stubby area it deals with the ASBR router and it will create LSA type 7. Yes, to take the external into internal. So that's good. Now go to this and area 3 with an SSA. I should see any adjacencies here. So that's cool. Now if you go to the router 1 and show IP root OSPF, it takes time. Yes, here is it. Look at this. I can see the external route, which is for EIGRP by N2. N2, it's the default. This is the OSPF NSSA type 2, and this is the default, like E2. E2 is the default and with metric 20, so that's good. Just let me just connect the chapter here, because I don't want to switch off that. Now like this. Yes. Now, sorry. So now we got this. So we can see N2. This is because directly connected to the router 3. But if you go to the router A, you will see by E2. Look at this. I want to show you something interesting here. Router 3. Show IP root OSPF. Sorry. Look at this. Here's I see it by E2. Sorry, here is E2, and E2, not N2. Why? Because N2 here, it's for LSA type 7. Yes, because it received by LSA type 7 and take LSA type 7 to redistribute it by LSA type 5 to the other routers by E2. So if you go to this show IP OSPF database, now you will see the LSA type 7, which works for ASBR. Here is it. Yes, look at this. I see this is the type 7, which is as external network. Take it from, yes, this is regenerated from router 1, yes, and regenerated from router 3, yes, and take this network and to the router area 3, and also regenerate from router 1. Here is it. I think the router ID of router 1. Let's just to is it the show IP OSPF? What is the router ID? Yes, the router ID is this for OSPF for router 1. So this is regenerate from router 1 and take this and this and this to externally, and it takes also, look at this regenerate from router 3. Yes, here is it, and take this network, this loopback, and this, and also the serial link also to make it externally to the router 1. So that's good. So now what we have here, show IP root OSPF. I want to show you something also interesting. Look at this. On router 3, suppose you are working in this area, and router 3, it's an old router. Yes, it cannot yes, it cannot bear a very loading routing table. So you want to make routing table shortly with simple command. You can do this by using totally NSSA. You can convert this area to the totally NSSA to make like a summary for routing table on router 3. So what I want to do this, conf t router OSPF 1, just I want to make no like this, yes, and I want to make area area 3 NSSA no summary to make it totally NSSA. So now hit this enter. I should see the new adjacency. That's good. Let me just do show IP root OSPF. Till yet I can't see it. So yes, because I need to make this command on router 1 also. So go to the router 1, conf t. Now I want to router OSPF 1. I want to make no area 3 NSSA. Now area 3 NSSA with no summary. So now let's see what we have here. Now I should see it. I can't see. Show IP root. Show IP root. What we got here? Let me see. Yes, now look at this. I can see just this is the default route. Yes, I can see all. Yes, all. That's OSPF enter area. Yes, by this default route. So I make the routing table here is small, so that's good. So this is the advantage of totally NSSA. It will make the default route for all enter OSPF area. So that's good. Just accept this. Yes, accept this and two, which comes from router 1. Yes, because I did this, if you remembered, redistribute connected subnet, so it should see like the external route because they are external. So that's good. So that's very good. If you go to the router 1, show IP root OSPF, do you see anything change? we don't see anything, so that's good. Can I reach to any network to ping? Let's see, to the ping 8.8.8. This is the farthest one. Yes, I can ping to it by this default route. So that's good. We did this in area 3. So we did this area 3, we make it a stub, then we convert it into NSSA, after that to totally NSSA. We knew why stub area doesn't work in area 3, because router 3 here is the ASBR, and stub area it deals with type 5, and here is I need type 7 to redistribute the EIGRP external into the OSPF. So now we are going to the last point here. This is number 7. We want to make area 5 stub. After that we want to make it total stub area. Here is it. This is area 3, area 5. I want to make area 5 to make it a stub area, and after that I want to make it a total stub, and I want to see what is the difference here. So go to the router 2. First of all, go to the router 6. Show IP route, just to see what we got here. I see everything here as yes, everything. I can see E2 external route to the 9. This is for 9 here, and also for 8. Yes, here is it for 8. This is like enter area, OSPF area. So that's good. Now I want to make it, here is a stub, conft router OSPF 1. I want to make area 5 as a stub area, and go to the router 2, conft router OSPF 1 area 5 as a stub area. So that's good. Now I should see the new adjacencies. That's very nice. Now if you go show IP route, do you see anything here? That's good. I see all network here. So go to the router here, show IP route OSPF. What we got here? Look at this. This is very, very, very interesting one. SBR, it works with ABR, isn't it? So this is ABR, and this is the remote router. Look at this. In this router I can see the default route here, and also I can see all networks here. Yes, for all OSPF areas, and also, but I couldn't see the external. So before I did this stub, look at this, I could see this is the external E2. So but after that I couldn't see it, the E2. I see just the default route. So here is very, very interesting one. It converts the external routing into default route to reach to them. So if can I reach to the 9.9.9.9? Yes, I can reach to the 9.9, which is here in EIGRP in router 9 by default route. So this is the benefit of a stub area in the area border router. It's make the to the summary to the external OSPF area. So what I want to do also here, I want to make router 6 or routing table and router 6 to make it smaller than this. Yes, and I want to distribute it all of them by this default route. So what I can to do here, I want just simply to convert from stub to total stub. Yes, because here, look at this. Go to the router 2. Conft router OSPF 1. Just here is it. No, and area 5 stub with no summary, which is mean totally. So now go to the area 6. What we got here. until now not yet, because I should make router 6 also into, sorry, okay, so now no area 5 stub, area 5 stub, no summary, which I want to make it to total summary area. Now I should see just here is the default route. I don't want to see other network, so show IP route. Not yet, maybe it takes time. Yes, now look at this. Now I can see just the default route. I can't see any OSPF inter or intra areas. So this is very interesting one. Yes, to do it. So I make a summarization for all one without using, yes, a summary address or area summary. Area summary, yes, this is a very good one. So I can reach to any network I wanted, like 1.1.1.1. Can reach it, yes, to the 5.5.5.5. I can reach it to the 8.8.8, sorry, 8.8, what is that? 8.8.8, yes, so, and also 9. This is for AGRB external. Can I reach it? Yes. So we did this as a step to make our to make a summary for external into a default route. We did it for total stub area to make all routing tables in router 6 to go out by the default route. So final thing, we saw the differences between totally stub area and totally NSSA, and between the difference between NSSA and the stub area. So I hope this video it's very useful for everyone, and I hope to see you in the next video, inshallah. So bye bye.